A 3D shape consists of a hollow sphere made of metal. The diagram shows a cross-section drawn through the centre 0 of the sphere. So we've got a big sphere with radius 1.2 plus t. And then inside there's like a hollow sphere with radius 1.2. The internal radius of the sphere is 1.2. The thickness of the metal is T. The density of the metal is 2,700 kilograms per meter cubed. The mass of the 3D shape is 1,980 kilograms. Work out the value of T. Give your answer correct to two significant figures. Hopefully you've spotted this is a density question first of all. Density equals mass divided by volume. We have our density. Checking my units, yes they are consistent. Mass. So we can make V the subject here by timesing both sides by V. And dividing both sides by 2,700. I'm just going to work that out on my calculator, but I might just leave it as a simplified fraction for now, 11/15. So we know the volume of the metal bit here is 11/15. So in your formula book, that is the formula to find the volume of a sphere, 4/3 pi r cubed. So we can use that to find the value of T. So I'm going to work out the volume of like the big sphere, which has a radius of 1.2 plus T. So the volume of the big sphere is 4/3 pi r cubed. Now r is 1.2 plus t. Okay, that looks a bit nasty, but let's just leave it as it is now. Now the volume of the hollow sphere is 4/3 times pi times r cubed. Okay, so I'm now going to find an equation from this information. So we've got the big sphere minus the hollow sphere gives us a volume of 11/15. Now we can work all of this out. If I type that on a calculator, I get 7.23822. Now what I can do here is add 7.23822 to both sides. I'm solving to find T. That's my ultimate quest for this question. So if I add 7.23822 to both sides, I get 7.97156. I'll leave the full answer on my calculator. I can divide both sides by 4/3 pi. Which gives me 1.90307. Cube root both sides. and then minus 1.2 from both sides. So 2 significant, well, I'm going to write down the full answer here and then round it. Meters. This answer is T in meters because my volume was in meters cubed. We need to find out the value of T centimeters. 1 meter is 100 centimeters. So if I multiply this value here by 100 and then round two significant figures, I get 3.9 centimeters.